Good afternoon, I'm Soorya and this is my teammate Kartikeya. We both are going to give a presentation on LDR and additionally on its alternatives. So we have divided the contents into mainly two parts. First, we're going to explain about LDR and its setup and procedure, and then specially the second and special section is about the alternatives for LDR.
So what is an LDR? Light dependent resistors are a type of electronic optosensor. They alter their electrical characteristics in the presence of visible or invisible light. The resistance of an LDR varies inversely with the intensity of light falling on it. The LDR has a pair of metal film contact that serve as the electrical terminal. This metal film provides the interface for connecting the LDR to the external circuit. The space between the two metal film contact is filled with a snake-like track of cadmium sulfide material. Cadmium sulfide is a semiconductor that exhibits a unique property. Its electrical conductivity changes significantly with the amount of light that falls on it. The entire LDR assembly is housed in a clear plastic or resin case. This protective casing serves two purposes. It allows free access of external light to the CDS material, enabling the light dependent behavior of the LDR. It shields the delicate internal components from physical damage, dust, and other environmental factors. Image below shows the experimental setup of the experiment. The first image is the circuit diagram, and the second image is the uh, image of the setup. Experimental procedure for studying the LDR characteristics is as follows. Connect the circuit as shown in the diagram with voltmeter and ammeter in the circuit. Switch on the instrument using on-off toggle switch. Adjust the power supply to 1 volt and focus light on the LDR. Note down the corresponding current and calculate the resistance of LDR using formula R is equal to V upon I. Repeat step 3 for different supply voltages or different distances. You can see in this video, I'm pulling the light backwards, so the distance is increasing, so the intensity of light is decreasing and the current is also decreasing. My friend Surya will explain the different alternatives to LTR.
Photodiodes are constructed using a PN junction similar to a regular diode. When light of sufficient energy strikes the PN junction, it creates an electron hole pairs, which result in the flow of current in the reverse bias direction. Photodiodes can be designed to be sensitive to specific wavelengths of light by selecting appropriate semiconductor materials. Phototransistors operate based on the same principles as photodiodes, where photons of light create electron hole pairs within the semiconductor material. However, in a phototransistor, the resulting current flowing in between the collector and emitter electrode is larger. Transistors offer higher sensitivity and signal amplification compared to photodiodes. They are essentially a combination of photodiode and a transistor, providing both light detection and signal amplification in a single device. While phototransistors offer advantages in terms of sensitivity and amplification, they typically have slower response times compared to photodiodes due to the additional amplification stage. Unlike LDRs, which change resistance in response to light intensity, photodiodes produce a current proportional to the incident light intensity. This linear response makes them well suited for quantitative light sensing applications. Thus, in conclusion, both of these allow for low light detection or high speed response. Next up is photovoltaic cells. Photovoltaic cells, while primarily used for energy conversion, can serve as alternatives to LDRs in solar energy applications. They offer high energy conversion efficiency and are designed to generate electrical power from light. Photovoltaic cells are used in solar panels, solar powered devices, and renewable energy systems. Another alternative to light detecting sensors are based on quantum dot principle. Quantum dots are nanometer sized semiconductor particles that exhibit quantum mechanical properties due to their small size. Uh, some of the properties are quantum confinement. Quantum dots are so small that they confine electrons and holes within a quantized energy state. This confinement leads to discretized energy levels, allowing quantum dots to absorb light over a broad spectrum of wavelengths. The band gap of a quantum dot, which determines the energy of absorbed photons, can be controlled by adjusting its size. This tunability enables quantum dot photodetectors to be customized for specific applications requiring the detection of different wavelengths of light. Quantum dot photodetectors allow for efficient charge separation. Upon absorbing photons, quantum dots efficiently separate electron-hole pairs due to their small size and unique electronic structure. This efficient charge separation results in a measurable photocurrent, which is proportional to the intensity of the incident light. Quantum fabrication techniques allow for mass production of uniform and reproducible quantum dots, enabling scalable manufacturing of QDPs at a reasonable cost. The book in the image represents a comprehensive overview of the state-of-art quantum dot photodetectors, including device fabrication technologies, optical engineering, and manipulation strategies.
So LDR relies on the change in electrical resistance of semiconductor material, whereas CMOS sensors use an array of light-sensitive pixels to capture a digital image or measure light levels. CMOS sensors generally have a wider dynamic range and better sensitivity to light compared to LDRs. CMOS sensors can accurately measure and distinguish between different level of light intensities, making them more suitable for applications that require precise light measurement. CMOS sensors have better or faster response time. The faster the response time of CMOS sensor allows them to capture and react to rapid changes in light levels, which can be important in certain applications. CMOS sensors often come in with additional integrated functionalities such as on-chip signal processing, amplification, and analog to digital conversions.
So, in conclusion, in this video, we learned about LDR, its working principle, and the working procedure, and we went further to explore many options which could be used as alternatives for LDR. Thanks and have a nice day.